Okay, I had a couple students ask about this EZ3 6502 simulator. It's the old classic um, processor. And so we're going to go here and just walk through it real quick here. So again, this is one of the options for this assignment. And you can read through this. This talks about this is an assembly language program, so you hit assemble and you can run that. You can actually step through it, but I just find just hit run and it'll run it. And what it's doing is displaying some pixels on the screen over here. If we look through this, it'll talk about the colors that we're using and the numbering systems that we're using here. So we are loading a number into the register here and then storing it in a memory location, which is actually a screen. Old computer systems used to have what is pixel mapped memory. So in a certain area of memory, if you wrote to a certain pixel, that would change the color of a screen there. I remember running my first programs for an old Apple II, and we had to program graphics that way. There was a set area of memory and you could write values to it and you could turn on and off pixels here. So that's what this is doing. L is load into register A, and store is store whatever is register A into this memory location here. So that's what we're doing here. So what are the values for this? So we're working with colors here. So in this emulator, there are 16 different colors here, and these are written in hexadecimal. In this emulator, and a lot of them, anything that starts with a dollar sign is a hexadecimal numbers. Now you may remember your hexadecimal numbers here. They are, let me see if I can blow this up a little bit more. Two-digit hexadecimal numbers, oops, sorry, let's see if I can stop this there. Two-digit hexadecimal numbers use the digits 0 through 9 plus A, B, C, D, E, F to get 16 digits. So here are the first 16 numbers, and then here's the next 16 numbers, and the next, and here. See, these are all the 16 two-digit 16 decimal numbers for this, and they go from 0 to 255 for those values. Here we're just using 0 to F, and so that is just this top row. There are 16 different numbers here, and each one of these is a different color. So those are our color values. And the memory locations are 4-digit hexadecimal numbers starting at, I'll just say 200 here, and going up into, let's see, where's the top one? Yeah. 5FF. So basically it's going from 00 to 5FF kind of here. Again, that's 4 digits, so this is only 2 digits, but you get the idea here. So when we run this here, it'll load in color 1 into the register and write it to the first value, which is 200, and then load in color 5 and write that into the next value, which is 201 here. So it goes 200, 201, 203, 204. So again, and load in the next color and write it to 202. So if we want to change location here, let's say 200 is the first one. Let's say we want to do, so 200, let's say we want to do over 4, so 204 for the next one. So this would be 204. We'll write it down. And then we'll do a couple more. Let's do 208. Here's the last one. So these will be our pixel values. So we can assemble this and run it. And now they'll be kind of spaced out. They're running at the 00 location, 201, 204, and 208, 208, those values. Now, if we want to change the colors, again, there are 16 colors. I don't know exactly what the colors are. So one is that 2 and 3. Let's just do 1, 2, 3 to see what those colors are. So these are 1, 2, 3. And again, these are usually just random values. Original Apple and IBM computers had a 16 kind of random colors. I don't know if you've ever looked at retro graphics, but all of them tend to use the same 16 colors values here. So, okay, so what you want to do is try to change the colors of the pixels. And again, you can change these values you just have, it has to be a 0 and then something between 0 and F values here. So one of these digits on this top row is 0, 0 to 0F is the colors. And then the locations have to be something between 200 is the first pixel, and the bottom pixel again was 5FF. So if we wanted to write one to the very end, we would do 5FF. Here's assemble and then run, and then we got that pixel and that pixel. Now they go across the street, across the screen here. So let's just try 200, and I'm going to add another line here. We can add as many lines as we want here. I'm going to add one at the end of this line, and I think that is instead of 204, 1F. I did a little experimenting there, and I think because I think 220 is the start of this line. So now if I assemble that and run that, you'll see pixel here. This is 021F is at the end of this line, and then 0220 is the beginning of this line. If I wanted to do one more here, that would be, I could do another pixel. Maybe I'll do it a slightly different color. Let's do color 3. And again, that would be 1 would be 1 pixel over here. So if I run, now I've got 2 pixels in a row there for this one. And then you can draw these out. Now I'm trying to remember, so that again, the end of the line is 1F here. So I think 3F is the next line. So it's kind of, you can kind of see there's actually, I think, 32 pixels across. So we do 16 and 16. So 1F would be the next one, and then 3F would be the next one, and 5F would be. So I think there are 32 pixels in this little screen here. So you can kind of count linearly as you go where all the pixels are. Okay. Hope that helps you here. Let's see, what are you supposed to turn in if you do this? Oh yeah, just submit the assembly language and structure. You can just grab that assembly language that you've tried, some of this sample assembly language, and submit that. Okay, hope that helps.